Hey, welcome kids.
Welcome.
Welcome to you, Camel. How you doing, man?
I'm doing pretty good. How are you?
I'm a little bit worried about our upload speed right now.
Uh-oh.
Got my eyes on it. It's looking pretty low. Hopefully that'll kick in. It just dropped to 0. That's not looking good at all. Back down to 0. I'm gonna check the quality online and see what it looks like. You're doing a test right now?
Yeah.
Speed test? Okay, let's throw in a speed test at it. Yeah, it looks pretty low. It's a better way to do it. All right, looks like we are back. We're back again, Campbell.
Okay.
Yeah, we were screwing through a VPN. That's why we had low numbers. I should have smelled the problem and fixed it sooner. Anyway, go ahead, Campbell. This is a great way to show what you're talking about, I think, by the way.
So yeah, we can change this operator to this. We can also do subtraction, addition, and we can have decimals, negative numbers, mixed numbers, anything like that, and we can add, subtract, multiply, or divide by any number.
Yeah, we also were talking about a button to convert to fraction.
That is true. So you could have 7.892, and then the button would be convert to fraction, and it would change this into some fraction. Or a mixed number.
Yeah. I'm also thinking about why not just show the fraction always. Thinking a little bit about that. So in other words, we always show the decimal and we always show the fraction. So if I type in 7.5, we'll see 7.5 there, but we'll also see 7.5.
Oh.
So we don't have to hit a button. It's just always visible.
Maybe.
I think I want to start that now is what I want to do. I want to do that now instead of doing the units.
Okay.
But we can also do the units if you want.
Yeah,
I don't know, what do you want to do?
let's just do so that it shows the fraction always first.
Okay. So if we're going to do that, we need to change the UI a little bit on
We
that.
need to add a text block.
Yeah. If you want to go ahead and once you start that right up there, I'll let you go ahead and I'm just going to move my mouse out of the way. Just give yourself more space though. Get rid of that. Yeah, there you go. Good. So Campbell's in SAML right now.
Text block is just TB, right? And
yeah, TB is in fact if you look at look at label. See where you have the word label below you?
yeah.
Text block and a label are both similar. That label is where we put the answer. See what its name is? Label answer right there. So you could duplicate that line that you're on below you, the one you're currently on, and use that as a model for your fractional answer. Call that answer fraction, and the other one we would call answer decimal. But here's the thing, and I don't know if we'd have any content here. I think on the second one, wait, don't rename that one yet. And the reason why is because when you just type in something here, it won't rename it. You have to use the refactoring. But hold on, Visual Studio's rename refactoring isn't available here. Okay. However, CodeRush makes it so that when you use it on the other side, you can rename and it'll find us. I'm pretty sure we're still doing that. But before we leave here, I want you to enter an equation above the second one.
Just delete it.
Yeah, delete the second one. You can use selection increase here, by the way, that big fat plus button, the plus button on the numeric keypad. There you go. And just quickly get it and then hit delete. Okay? So hit tab to make reference on label answer. And now you can rename it from here.
Okay. Oops, that's not the one I wanted.
My mouse on the machine or something? Looks like there's a little jitter. I'm not moving my mouse. Is anything
Oh,
working?
it was because my mouse was here, so I would press the down arrow.
I think I understand. Okay.
I'll be all answer.
Oops. Undo.
Ah,
The right arrow
and
key?
then boom, and then
There we go. Good. Okay, now I will go get up on set answer and hit tab to next reference. Let's see where that's being called from.
oh wait,
That's it, just those two
just
places?
here.
Oh no,
I think
there you go. Display start. Okay, let's work on some code to convert fractions. I think the first thing we should do is create a new test case for
It should
converting
be
fractions.
quite simple because we already.
Will you stop with the, it should be quite simple?
No.
We have no idea at this point.
My thoughts are that
4
the
weeks
code,
later, we wrap this up. I'm sorry, go ahead, what?
My thoughts are that the code, it will just be, because converting to a fraction, if you have 1/2, it's just 1 divided by 2. You just take the fraction and put it into Visual Studio, and Visual Studio will...
Right, but if we have a decimal, if we have 1.23456, and we want to convert that to a fraction, that's what I want to write.
Oh,
That
right.
code. Okay?
That's right. But converting to a decimal.
Converting to a decimal is no-brainer if it's already there. In fact, this answer that we're sending here is, hold on, get over here. This right here, in fact, let's rename this to set decimal at, set answer decimal. Oops,
Didn't we just do that? Oh, right.
not the method. And
Was that
then we
with
might
the
also create a set decimal, set answer fraction. Like that. Like that. And there we go. So we got the second one we haven't called yet. We need to call that. I want to create some test cases first. Can you go open up our test project? You can get there quickly by double clicking any of those tests over there on the left. Oh, but you got it. Let's create a new test method.
That's what I wanted to do. T.
And let's call this test fractional conversion.
Oops, that's not what I meant to.
All right, let me throw something at it here. I'm just going to grab one of these assert equals here. Actually, I won't. Come down here, type in AE for assert equal. Expected value, let's say we're looking for 1/2. And we're going to come in, we're going to start off with 0.5. We're going to call toNum. And then off of toNum, we're going to call just call fraction string. Fraction stir, like that. Which doesn't exist yet. But that's what my test is going to look like, because I want it to look pretty good. That's what I wanted. I want the test to look pretty good. So let's declare this. When I say good, I mean easy. Easy to consume the test. So now we want to create a second test. We can come down here and say, okay, let's make a 1/4 and to do that. Does that make sense?
Yes.
Let's do, 1.25, and then what would that expected to be?
That would be 1 1/4.
Okay, so we're looking for that? Or would it be 5/4? What's our fraction string going to do?
I think it would be quite simple to just to make it so that it would say 1 1/4, but maybe we make it so that it says 5/4 or something like that. I think we do. We do the second option.
Or maybe we have two different methods or properties that we can have, right? Where we do this. So maybe this is called simple fraction string, and this is called, I don't know, whole fraction string? What do you think about that?
Yeah, I think whole fraction string.
I don't like that the word whole here is similar to whole number is in the one that doesn't have a whole number on it.
Yeah, that's true.
What if we made fraction string and whole number
maybe,
fraction string?
Maybe exact fraction string?
What if we did this? I'm not sure I'm into that exact. What if we did this? So whole number fraction string gives me this.
Mixed number, I think.
Is it a mixed number?
It is, because it's a fraction and a whole number.
Then we'll use that. Okay. Mixed number fraction string. All right, so those are the two we're going to create. All right, so let's build them. Declared property with default body. And this is going to be a calculated, it's going to be a calculated piece here. I want a little more body here is what I'm going to do. So I'm going to do that. I use CodeRush's expand body because I want to, I think there's some logic down in here. I think the logic, can you help me with any of the logic here? Do you have any ideas on what we're going to do here? Like, do we want to do any logic that's dependent on the number type? Because the number can internally store itself as either a decimal or a fraction.
I think, well, we do need to know if it's, whether or not it's a decimal. Right? Or
okay, so part of the logic is going to check to see if R is type equal to number type dot decimal. That's our storage, our internal storage, right?
Yes.
So if it's internal, if it's a decimal, well, I'm going to put, we need to convert to a fraction. That's for sure. Okay, let's look at this block right here. What's happening here? If we're not a decimal, what does that mean? What type are we?
If we're not a decimal, then we're a fraction.
Okay.
And, well, we would need to convert to a decimal for the first answer.
You see, we need to convert to a decimal?
We don't need to, but...
No, we don't. No, we don't need it. It's because we're returning a fraction. What do we return here?
Oh, this is for the fraction string. Just,
right.
Just the current fraction, so...
Kind of. We said the fraction string was going to be not a mixed number fraction. It was going to be one number over another.
Yes.
So like 5 over 4 instead of 1.
So it would be the denominator times the whole number plus the numerator.
Yeah.
And then that over just the denominator.
Can you write that code? And give it to me as a interpolated string.
First I'm going to write the interpolated string.
Actually, you want to do R first to get your return? You can copy that to clipboard if you don't want to type that in again. R space to get your return. Then your interpolated string. Right, we just take it a piece at a time. Right? Okay, so Campbell's got this interpolated string.
Okay, so here we want, not that, we want to have the numerator times the whole number Can I use parentheses in this?
You can, but you don't need them because of
oh right, PEMDAS.
Because operator precedence happens in source code too.
Plus, right?
Mm-hmm.
Oh wait, the numerator is wrong. It's
I thought that was right. Tell me what's happening now.
It's not numerator, it's denominator times the whole number.
Oh, you're right. I wasn't thinking, was I?
Denominator.
Control space will get you the case correction on that. Anywhere on there. Control space, there you go. Denominator times the whole number plus, good catch.
The numerator.
Guess who missed that completely? Control space. If it doesn't work here, left arrow and then control space. It's right there. I'm not sure why that's the deal.
Numerator, and then
that's our top number.
The denominator. Wait, no, not with the spaces because.
Yes, that's good. I love it. I love it.
Wait.
Go ahead.
I think we should do an else if.
No, because there's no other case. We only have two number types right now.
Yes, but we only have a decimal and a fraction.
Right.
But if we don't have a whole number, then there's no need for doing this code.
Oh, then we need another if down in here. So basically, we want to say if. Well, here's the thing though. If whole number is equal to 0, this is just going to go away. See that? Because I've got 0 times denominator.
That's
whole number
true.
0. So it's really, this is really all we need. But it's a really great point to be thinking that, right? Do we need a check here? That's a great thing to be thinking about. All right, next, decimal type here. This is going to be, we need to convert to a fraction, and then we need to call fraction string on the converted piece. So I think what I want here is I want to say convert to fraction. I want that to be a method that returns a one of these SuperNumbers. So instead of returning void, I'm going to return the class that I'm in here, SuperNumber, like that. And then so what we're going to do here, well, we'll figure that out in a second. I'll drop a marker there. After we do convert to fraction, I want to, because it's a super number, I want to then call fraction string on it, and I want to return it. So the simple code here is just that. And I don't even need that comment anymore. And I can get rid of these block delimiters and these, right? So if it's a decimal, then we're going to convert to fraction and call fraction string on it and return that. But when we call convert to fraction, we are not going to change anything inside our super number. We're only going to create a new one and get it out of there, okay?
Oh, okay.
So we're going to say return a new super number, and we want to pass in the top number. I guess we'll say numerator and denominator. These are going to be local variables I'll need to create. Okay, and do I have an override that just takes 2? I don't, so I'm going to have to pass in 0 as the whole number. So we've got 0, numerator, denominator. Cool with that so far?
Mm-hmm. Yes.
All right, these are both ints. So VI for variable type int gives me that, and this one's going to be denominator. I thought I could get close. Okay, denominator, like that. All right, so let's say numerator is equal to value. That's a decimal.
Yes.
Right?
Value is a decimal.
Now we need to figure out how many decimal places it has. And I don't know how to do that in C#. Not something I've done before. C#, how many decimal places in a number? And so I'm looking for, wait. We converted to get bytes. What? Hold on. Wow. That's some crazy code. Hold on, what's this? I can only assume colossal mind fart virus attacked everyone 3 years ago. Holy cow. It's got 25 upvotes. Wow, there's so much discussion on this. This does not look like an easy problem to solve, apparently. All right. I'm going to take this code right here. I don't understand it, Campbell. It looks like it's looking at the way the decimal is stored, and from there, it's determining how many storage locations are here. I'm going to use that, and we're going to see if we can make that work. Okay? That is, do you have some problems with that code because it's so hard to understand? What'd you say?
I don't have problems with that piece of code, but I had problems with somebody else's code where they wrote the answer, they just hard coded it, and they said 1/3, I think that's
Is something in here?
Yeah, here.
This one?
Yes. No, not that one. The one below it. Up, right above, right up,
Good, you can find it.
right here.
Oh, those are the tests. Those aren't hard-coded.
Okay.
So basically it's saying, look at, here's the tests on running all of this. So we get 0 for that one. We get,
No, we get 1 for that one.
what'd you say?
We get 1 for this one.
Well, in the previous example, this is different code, but here's the comment, shows what the value is for it.
I guess.
This is what we want. So this works for me here. Make sure it's positive, remove the integer part. Yeah, this is kind of what I was thinking about writing, something like this. This I thought was really fair. Let's go and take this. This is easier to read. Would you agree? It's easier to understand, at least. It's
Yes.
more code.
But
it-
the other code is just you,
Like
you
this,
see it and you're like,
yeah.
what?
Yeah, I think that works because of, I think it works because of the way the number is stored. So it depends on knowledge of how it is, how it's stored. Oh, interesting. This is like remove the integer part of the number is n minus equals int of n. Oh, wow. So so imagine that n was like 1.23. Like that. That's n. Then we say n minus equals, we say that minus equals int of n.
So that would be 1.
Right, which is 1. So we're basically saying that minus 1, which is
That
equal.
minus, and then you convert it to an int.
Yeah.
That's
So it's kind of like this right here. It's like that's what's happening. 1, 2, 3, 4 minus equals 1, which is int of, int of n, which is 1, which is equal to 0.234. Okay. So we do that here, and we do we do that there, we do it here.
yeah.
And then what we do is we start counting the decimal places, starting at 0, while n is greater than 0. So n is whatever is whatever's left over. So this is greater than 0 right there, right? So we're going to increase the decimal places. We'll multiply n by 10, which means now we're at 2.34 with the sample data, right? We start here. You following what I'm writing? Make sure you're following this because this is...
Not really.
Okay, so let's do it again. Look right up here. You saw this, right? That I go from 1.234 on minus equals 1.
Yes, yeah.
Which leads me to 0.234.
Yes.
So that's what n is.
That's what I understand.
N is equal to that right now. So n equals 0.234. Okay? We'll just say n equals 1.234 up here. So you can just kind of follow the data. I'm just doing it in comments, right?
And then you multiply by 10.
First time in, this is true.
Oh, okay.
0.234. It's true, right? N is greater than 0. Decimal places goes to 1. N times equals 10, which means n is now equal to 2.34.
Yes.
Okay? Then we do this again. which means now n is equal to what?
N is equal to 0.34.
Perfect. Okay, good. We end the loop, come back up here, evaluate the expression.
Still true.
This time, we're the second time, and n is equal to 0.34.
Oh, I see where this is going.
Okay, then we increase this now to 2.
To 2.
I'm going to put a semicolon indicating each time we pass by. Okay, then down here, n.
Now it's 3.4.
Oops, yeah, so now we're at n equals
3.4.
3.4. And
now it is equal to 0.4.
Yep, n equals 0.4.
And it's still greater than 0, so when we end the loop and then go right back up.
True? Right?
Oh,
now we're done.
This is awesome code.
Yeah. Now we do this, and now we're at 4. Right?
And then you take the int
and n is equal to this, and now we're at 0.
And it's
0.
no longer greater than 0, so we don't repeat the loop, and we return the decimal places, which is now 3.
There you go. See it?
Yeah.
Seeing and understanding how code like this works, right, is kind of cool. Right? Kind of, we're like, okay, that's a cool use of the while loop. Right? Clever. And often in understanding code, I find it's really good to step through it with a good example, or you could do what we're doing here if you don't mind typing in a lot of comments.
Yeah.
But I kind of like this, seeing this data in parallel for the different passes. It's kind of cool. All right, should I keep those comments in place there or delete them?
I think we should keep them just
okay.
so that we can look at it later and be like, oh, okay.
All right, cool. So now I've got get decimal places. So now I want to call, I want to have a number called decimal places here. And set that equal to, that's in a class called SuperMath, I think. SuperMath dot get decimal places. So that's the one we just copied from Stack Overflow.
Yes.
And we're going to pass in values. Okay? And then we're going to say numerator is equal to value times math.how of 10 comma decimal places. I think this is correct math. So for example, if I have 0.5, let's look at an example of this, okay? If I have 0.5, my decimal places is going to be 1. Right? Mm-hmm. Then we're going to say the numerator, and we got a problem here probably because I need to do an int on this like that. Is that it or no? What's my problem here? Can it convert decimal to an int? Oh, it's not here. It's here. So the numerator is equal to the value. Well, it's actually not the value. Wait, is it right? Yes, it is. But it's this typecast as an int, this whole piece right here. Okay, now what's my problem in here? Runs of decimal and double. Okay, so we're going to cast this as a decimal. Now everything should be okay. All right, a little bit more casting than I prefer there, but should be our new numerator. So in our example down there, what that means now is our numerator is going to be equal to my value, which is what in the sample?
It's
there, I left a hint up there on line 318. What's our value in this sample?
Is 1/2 or
0.5. So numerator is going to be equal to 0.5 times 10 raised to what power?
Raised to the power of decimal places.
Which is?
Which is in this case 1.
Which means this numerator will be what?
5.
5. My denominator now, we have to figure out that. What's the denominator to make this right? What's the equation? What do I need to make 5? What 5 over what? So the question is 5 over what is equal to, maybe I'll call this D for denominator, is equal to 0.5.
10.
10. So we solve for the denominator is what we do, right? So if we flip both sides, right, we can flip both sides and we can say, oh, okay, d over 5 is equal to 1 over my value, right? And this is my new numerator.
Yes.
Right over there as well. Actually, you know what? I want to back up because there's a faster, easier way to solve this. I just realized. When I wrote this down, 5 over what value is equal to 0.5? And you said the answer was 10, right?
Mm-hmm.
It's the same as this guy right here.
Yes, that is true.
I lost track of that. And that's true no matter what. So we're going to call this maybe we're going to create a variable called 10 power, something like that. And that's going to be equal to 10 to the number of decimal places. Like that. And then we're going to use 10 power here. Numerator is equal to value times 10 power. Denominator is equal to oh, hold on, I got a call from Mom. Everybody okay? Holy shit. All right, excuse me everybody for the, well, is there something I can do? Do you realize that you've called me twice and I've sworn on the show both times? Yeah.
Dang it. I was trying to press excuse me.
Maybe there's something I can do remotely. Why don't you, let's think about that. Send me text and keep me updated, okay? Okay, bye-bye. Oh my goodness.
You know what we should do?
What?
We should make it so that if the fraction is 1/3, we just don't convert it into a decimal. In our other piece of code where we can.
What do you want to do? Throw an exception? Say that it can't be converted?
I think we just shouldn't show the text box. Just have no value in the text box.
Okay. All right, we can do that. So anyways, back down to here, we were basically like saying the denominator is equal to my 10 power. So my 10 power is this right here. Ten power. Like that. And I almost want to just, 10 raised to any number is going to be an int. So I'm just going to cast it to an int right there, not a decimal. Okay? And then, so my numerator is equal to value times 10 power.
Yeah.
No, I'm sorry, not value. Is it really? Oh yeah, that is right. It is value
Yes,
times 10
it
power,
is.
that's right. And then my denominator is equal to 10 power. And actually, now that I see this, it's occurred to me that I really don't need 10 power anymore. I could do the same code here. Denominator is equal to that, and the numerator is equal to value times denominator. This is weird though to read, harder to read.
Yeah, I think we should go back to 10 power.
There you go.
Because having the numerator equal to something times the denominator, it's I know it's the same here, but it doesn't quite make sense.
Okay, then we have, I think, a simplified call.
We do. It's pretty simple.
And that's going to return a new simple version of that SuperNumber. So convert to fraction may be done. Let's go look at it here. Fraction string may be done. We have test cases for fraction string.
We do.
We don't have this one.
Oh, we don't.
What does simplify do? Maybe simplify
It
is not
finds
the
the
method.
common factors of the denominator and numerator and divides both of them by that.
Yeah, but what does it do with a whole number?
I'm not sure.
I hit the wrong key.
Wait. Do you think simplify?
Make fraction
Makes it-
proper. It gives us a whole number.
It does. Okay.
Create improper.
That is.
Yeah. You might want to call it create improper. For the fraction. We're trying to, isn't fraction string? Yeah. See what we're doing? One thing over the other. So, simplify dot create improper like that. Convert to an improper fraction. Right, that's what we're calling it, right? Improper
Yes.
if it's got a larger number on top than the bottom.
Yes.
I hope that's the right word.
It is.
Okay,
I'm pretty sure.
okay. So convert to improper fraction. Or maybe not. We go back to convert to fraction, and I'm going to take this call and get it out of here and put it here instead. So if we're a decimal, we're going to, because fraction is going to return improper fraction. In fact, let's rename this improper fraction string. Okay, good?
Yes.
All right. Does that mean the other one is a proper fraction string?
I think we should leave it as mixed number.
Really? Okay. All right, we'll do it. That's fine. All right, so we got to implement that. And I'm going to just duplicate this. It's going to be similar, I think. You take a look at it and tell me what you think. What should we change?
Well, these two pieces, I believe. Right? Because we're trying to convert it to a decimal number.
No, we're not. Look at the name. It's a
Oh,
mixed
right.
number fraction string.
Yes.
That's the
sorry.
property.
So we want convert to fraction, but we don't want create improper.
I agree. Is there a wait? Hold on though. Is there a
There's a create proper.
create convert to fraction? I think that's already automatically going to be mixed. Going to be there, and then we're going to return mixed number fraction string. We're going to come back in and call this on the converted piece. That type is not going to be decimal, it'll be a fraction, which means we're going to now jump down to here. What do we do down in here?
Okay, and here we want, we don't want to do this. We just want the numerator over the denominator, and then but we want one more thing. And that is the whole number in here. And that is it.
What if the whole number is 0?
Okay. If whole number.
You can do a space after if and it'll create the parens for you automatically.
That's what I tried doing it.
Try it again.
Okay, one sec. To 0. Then return. Oh,
Just R space.
I remember. R.
You've got that line below you that you could copy or duplicate.
That's true.
Drop a marker there too if you want to jump back quickly. I know I'm throwing a lot of stuff at you at once. All right, that's up. I like to put my ifs at the end of my else's.
Ah! What just happened?
I'm not sure. I think I held the shift key down as I came in and you probably hit enter. All right, so I like to put my ifs on the end of else's here. So I just kind of show that this and these two are siblings in the sense that I could come here or here. I could add one more else here if I wanted to, and all three of these would be siblings.
Yeah.
But it's functionally equivalent to this, and the reason why is because
It is.
here I exit the method. Is that what you were going to say?
Yeah.
Okay. So now I think we can compile and the test cases might run. So let's right click here and say build. Now let's go to our test runner and run our test cases and see what trouble we're in. But this test divide negative we got to look at too. Test unit division, test mix num with decimal. Nope, that's not it. Maybe we haven't run them yet. Let's just run them all. See what's spelling. All right. I don't recognize the new test case we added. Does that mean it's passing? That must mean it's passing. What was it? Improper fractions? Test fraction conversion is what it was.
Test fractional conversion, it's passing.
Double click it.
No, wait, that's not it.
That is it.
Wait,
that's
no,
the one we
that
just
is it.
wrote. So it's entirely passing. All right. That's excellent news. Let's figure out what's going on everywhere else. Test divide negative. This is a bug we found before. What's going over here? Yeah, okay, good. Test like units. Yeah, we're expecting that not to pass because this is new stuff we haven't done yet.
Yeah.
This is new. And unit division, same thing. Where we have units in there. We're not supporting units yet, but we expect to. Test mixed number with decimal. Yeah. It doesn't like numbers like that.
It does not.
I almost want to argue that's not, nobody likes numbers like that.
No, nobody does.
But you want to support
But-
these, right?
I think we might want to. I think.
You
We don't
wanna
have
do it.
to.
It's up to you. This is your program, man. You can own it and do whatever you want.
Then let's do it.
And then units power are not passing. Those, so all the ones that are failing, with the exception of test divide negative, this is one that blew my mind. Right? In other words, if we come in here and we say, let's do a couple of variations of this. Let's do this. Let's do this. And then let's do this. I think all of these pass except for the last one. Is that true or not? Or is it just this one? Is it just anything with a negative on the right that's passing, that's failing me?
Why do you have two of the same? You have 1 2/3 divided by -2 1/5, and then below that you have 1 2/3 divided by -2 1/5. Right below the one you have here.
Oh, right here. I see, you're right.
So a negative on that.
That should be -1 there. Also, this should be negative, and
Yeah.
this one should be negative for that to work. All right, let's put these in the order that I think they're going to pass. I think this one's going to pass, and
The positive's definitely going to pass.
yeah. Well, let's see what happens. There's something about this that one fails. Let's see if this one
Try.
succeeds.
Yeah.
Is it just that we're getting
On the
into
denominator?
here negative for the denominator?
Yeah.
Oh.
Okay. That's an easy thing to fix, I would think,
Do you know why?
because
We're throwing an exception. Denominator must always have a positive value. But what's interesting, I think it's 11. I'm getting -11 as the denominator. I think we're going to have to debug this and step into it. So let's do that right now. Is that cool with you?
it must think it's simplifying.
So we're basically going to jump into this num to num call right here. And the left is 1, and the right is, uh-oh. Well, no, I guess that's right.
Technically, yeah.
We have 2 and 1/5. So now we're saying left divided by right. And it's saying the answer. Hold on, what's our call stack? Here we go. Here we go. The problem is initialized fraction. We're passing a negative number in. Okay? See it?
Yes, I do.
From here, let's see, create reciprocal. Got it. So here when we create the reciprocal, our new denominator is a negative number. See what's happening?
Yeah.
We want to switch the signs of these two numbers if it's negative. So I guess what we want to do is this, is we want to say, hey, if new denominator is less than 0, then I want to say, how do I switch a sign?
It's math.sign, right?
I can do that.
Oh wait, no, you just multiply times -1.
There you go. There's another way. Good job. Yeah, you can do both ways of doing that. So I'm going to say new denominator, but I want to change the sign of new numerator as well. What do? You want to write that code?
Yeah.
New numerator's on the clipboard. Oh, you left a line that was your awesome source for your smart duplicate line feature.
Yeah, but it's
That's all right. You can do it all by hand. That's totally cool. Good job.
And then here it is.
Good job. Now I think this might work. That was a great bug to find. So back over in fractional tests, I think you'll be able to come in here and say stop debugging, or maybe it's done it. And then let's just run the test and see if that small change fixed it. Sweet, that passes now. So our failing tests now are all problems with units. Well, guess what makes sense? It makes sense to create a new test class to put the unit tests in, so we don't get this really big. Does that make sense to you?
Wait, sorry, can you say that again?
Yeah, no, go ahead. Go ahead and fix your camera.
I'm trying.
Oh, but I like your hand in focus. That's awesome. There you go. Now you got it.
Okay.
No sudden movements. I know you're a kid and that's all you do, or sudden movements. Yeah, stop it. Stop it, Dash. So we want to create a new test class here. I want to organize all these failing tests. I want to put them in another test class.
Okay.
So that I can organize them, and all the ones for that, I want to do that for the new feature, because it's all for the new feature we're about to write, which is units.
Yes.
So I want to create a new test class. To create a new test class with CodeRush, you just use the letter T. You just expand it there. CodeRush knows you're not inside a test class, so instead of giving you a test method, it's going to give you this. So we're going to call this unit and variable tests, I think, or test variables and units. Test units and variables, something like that. Units, variables. Test units, variables. And get rid of that S after the word test. It's great. Don't forget about Alt, left, and right there.
Yes.
And then you can hit Enter on that. And it takes you what?
Did I do something wrong?
I think you just know you hit Enter, and now it brought you down here. This is our first test case here. You can delete this test case. Use selection increase to get the test. The test case there, you're going to hit delete. Now you want to go use selection increase again. There you go. See how it's showing you up at the top?
Yeah,
that
the top.
Test class is selected. Just hit the left arrow key now.
Wait a minute.
Hit the left arrow key. You don't have to scroll up. It's a quick way to get to the top.
Yeah, but I think that's a mistake. You don't have. It won't show you the It doesn't show you the bottom of the selection.
Oh, I see. Okay. No worries. Well, you scrolled it. You did scroll it, and we saw it before. So now what I want you to do is put the caret on the word public down there. I want you to hit the CodeRush key and choose Move Type to File. There you go. Good. Next, I want you to go back to the other test unit case. So Control Shift Tab to get back to the previous file. Is that it? No. Control Shift Tab, I think. Oh, maybe it's just Control Tab. I was wrong. So Control Tab takes you the other way. I want fraction tests.
Oops.
It's up 2 from there. So yeah, no, this is a great keystroke to practice here. Control Tab takes you one way to recent stuff, and Control Shift Tab takes you to old stuff. Okay, so fraction tests. I want you to find all the ones that are failing. Oh shoot, we got to rerun them. All right.
And then you go to them and you double click.
I want to move them.
And you move type to file.
Yeah. Well, no, not move type to file. With these, I want to use shift select them all, cut them to the clipboard, move over to this guy, and paste them in.
Is that a CodeRush feature where you can that you can shift select them?
No, I was just holding the shift key down and moving up through them, paging up and down, that sort of thing.
Wait, so if you go shift, boom, and then can you also, no.
You shift click. So So you click at your starting place, whatever you want the start to be, like here, and I move down to the end and I shift click to grab it.
But wouldn't that grab the other methods?
It grabs everything between the two pieces.
Yeah.
The failing tests were all next to each other.
Really?
Yeah, they weren't next to each other here because they're sorted alphabetically.
Wait a minute. Can I try something?
Yeah, let me. I want to fix this to num because it's making me crazy. But yeah, go ahead. What do you want to do?
Can't. I was trying control select. You can't select two different places at the
No, CodeRush adds multi-select though, but it's not like fully featured. It's not fully featured. All right, let's figure out why toNum's not working. We just have to use. We're missing a using statement. Remember, toNum is coming from our extension method?
Yes.
Do you remember what an extension method is?
Yes, an extension method is a method that you can call from any class and
from any instance of any class.
From any instance of any class, as if it was from that class.
Yeah, and so this string must be an instance, therefore, it's an instance of a type. And so we're calling toNum on it. Yeah. So I just have to do that, and now those all are there. So at least now all of our failing tests are going to be in one place. So we have a place to work, and it's organized. Organization, as your code grows, Campbell, is really an important thing to tend to. It's kind of like if you drop a glass on the floor, it's a good idea to sweep it up.
Yeah.
Okay, so now, right up here, see the icon? Test class, here's everything that's failing.
Well,
and if we go back to the other test piece, which is fraction tests,
it's more like if you're making a mosaic, and the bigger it gets, the more you want to sweep up those little shards of whatever ceramic.
Yeah, you want to organize. Always organizationally. You always want to be keeping track of organization. Make it easier on yourself. So yeah, that worked. So yeah, these all pass, and the other ones all fail. All right, so let's look at the failing test cases over here in test unit variables. Let's pick something simple, and let's fix it. Maybe we have no choice. Maybe we just have to go. Let's just mix number with decimal. Oh, this is different.
It is.
This is a different failing test. I'm going to create a new test class, and I'm going to put it in there. So I'm just going to hit the word T. Whoops. T. Is that not working? Why didn't that work? I'm using it right up there. Oh, is it because caps lock is on? Caps lock. I'm sorry about that. Test mixed number fractions. So we'll have this as its own piece right out here. And then I'll just paste that test method in there. And I'll move type to file. And just also speaking of organization, we've been doing a lot of moving the type to the file. If we go back to Solution Explorer here, here's our SuperCalc test right here. Let's close everything else down. So we're just looking at one thing. You can see we've got these three files. Fraction tests, mixed number, and unit variables.
We might want to move some of the other mixed number tests into here, because into this test class, or wait, not this test class.
Okay.
Into
its own, maybe?
This. So yeah, we might want to move. Do we have any? I feel like we should.
I don't think we have any others. I think that's the only one, but maybe. All right, let's switch over to my machine real quickly. And talk about, what is this? What we've learned. We wrote this down, I think, last week. Units and variables are so similar, we should consider adding both at the same time. Units and variables can be I was talking about different ways to store them, and ultimately I decided to dismiss both of these ways, and I'm going to indicate that with strike through and gray. And I decided to go with just the simple units and variables all have powers.
Yes.
Okay. And all right, so what I want to do here, this is what the structure looks like. So for units and variables, each super number will have a list of units and variables, because they're pretty much, totally, the same functionally. They're functionally the same.
Yeah.
We haven't found an example where they differ in terms of what you need to do when you're multiplying, that sort of thing. Each unit and variable each unit and variable will have two properties. One, its name, and the other, its power. To what power is it raised? You with me on that, Camel?
Yes.
Okay. We need to find, so strategy. We need to find the place where we essentially parse numbers from text. We need to intercept that. And parse units out first. I want to support like that, and I want to support, let's go over, I've just got the old code here on my machine. Where are you? Like, really, I'm looking for that comment where we have the powers. Have the word birds in here? There it is. There's that. There's the bigger, longer comment. It's got all of those in it. There it is. That's what I was looking for. I want to support these characters. Superscript. Including this one, which I think I'm going to use as a minus. There might be a better way to do a minus. It probably is. Something that looks way better than that. I haven't found it yet. So yeah, Campbell's like bringing up Supermap already.
Yeah, this is the one you're using.
It's tricky to find. The way to find it, by the way, Campbell, is to put one of these down and then try to put the other one down next to it and see what it looks like. I'm double clicking this, but it's not coming down. Why not? Why's not coming down?
You have to click it and then hit select. Do you know that?
Try it. I'll do it. Select. Yeah, no. Double clicking is what should bring it down. That's how I got the 2 down, as I double clicked it. I'll let you play with that if you want to. But put it down next to it. You can hit copy and then paste it down here. That's also maybe a better way. Oh no, wait, copy is going to copy. For some reason the soft hyphen's not coming down. Don't click on other characters. There you go. See, that worked. Why didn't soft hyphen work? Try again on soft hyphen. Okay, I'm just like kind of stunned. But I'm pretty sure that's not going to work.
Yeah, select works as well. Clicking select.
So it's just not working for that soft hyphen. We have found a bug in character map. A product that's been out for like 10, 20 years.
No, that's not what we want. Oops.
Yeah, too low. Right? So we gotta keep searching.
For some reason, scroll wheel isn't working.
Yeah, I think you have to drag it. Here, let me I know where they are. The math characters are tend to be down below.
Oh, wait, I just found one. Oh, wait, can you bring it back to there? Stop.
You know what though? It's got a special use. See how it's moved to the side?
Yeah.
Let me try something down here though. I just want to see what it's a combining.
Oh wait, I see another one. No, that's not gonna be working.
You want to make sure it's one that's modifier letter. Maybe. Some of these have functional purpose. That's not bad. Let's copy that for now.
Wait.
That's the one we were just looking at.
This is not the one.
See what it does? Hold on, we gotta hit undo. See what it does? It overlaps them.
Yeah.
So we need a little bit of space here. I'm going for this one here. That's my vote right now.
All right.
All right, we'll do it. All right, we'll do it. That'll be how we indicate a negative power. Some some variables is where I'm expecting that to be. I'm going to replace that with this. Better, way better. It's going to look good. Okay, so we can do that on our display as well. So we want to support, so basically, here's what we want to do. So we need to find the place where the parse numbers from text. We need to intercept that parser units first. That's our first step. You want to look through that code, Campbell? I have no idea where that is. Where would that be? How would we find that? Where would you start looking if you wanted to find out where we start, where we're parsing?
Wait.
Good intuition. Let's go to the Solution Explorer. These are your tests, and you're in your test cases.
Oh, right.
There you go, SuperCalc. That's a place. That's where a main window is. Now, properties and resources, those are things we don't really need to expand. Those are things that are not things we're changing. App config is also not something we're touching. Main window, we've made a number of changes to main window, right?
Yeah,
That's where we type those things in. And these are showing you all the methods of main window.
I know we have a try parse somewhere.
So if you're thinking about try parse, okay. Let's just think structurally. Let's think more abstract, right? What happens in our app that leads to a super number being created? Oh, Surly Dev's out there. How are you doing? Looks like no fanfares according to Surly Dev. I think I know why. I'm going to restart a couple things here. So more abstractly, Kimball, tell me what happens with our app.
What do you mean? Wait, what do you mean?
Well, what happens with our app? What does our app do right now? Tell me, just talking in general terms.
It
right?
solves what you put into the text box.
So you put something in the text box. All right. So let's get a little more concrete than it solves that. You type something in the text box, and then what happens? What do we do with that?
We take it to another method where we figure out what it is. We figure out the answer to whatever you put in.
Okay, so between those two, though, don't we create something?
We create a super number for each of them.
Okay, so sometime in response to typing something in up here, we create a super number, right?
Yeah.
This is one way to find it. So your intuition is saying, let's look around over here, right? This doesn't show us every call and every method. It just shows us the methods and the properties that are here.
Yeah.
We have this TBX equation. This is what we type into. That TBX equation is here. Do you see any clues down here in the XAML that might help us decide where we look next? Sorry I missed you out there in the chat. Groversaurus.
Probably in text changed.
Okay, so go inside text changed. You can tap the next reference from there.
Nope, not text change.
Not from there, but from the TBX equation
Oh,
text
right.
change. That's the actual method name. Okay, what happens in here?
Well, first we say we don't show any errors because we've just started it up. So there's no, if the values are empty, it's because that's their default. And then we set the answer to enter an equation above, so that where the answer would normally be, it just says enter an equation above. And
You're looking at this code.
I am.
And that is only executed if the text is empty. And then we return it. I'm just shortcutting it and saying, okay, good. Awesome. What else happens down here? What's going on down here?
We set the super number equal to what we put into the text box.
Okay, so we want to intercept this, right? We don't care about anything else after. It's only when we convert the text box to a number.
Yeah.
So where do we go next? What do we look inside
We
next?
look inside of 2 now.
Okay, fine. Let's go do that. All right, and let me do just a few more things on getting. Hold on, I'm switching my machine for a second. I'm going to do a refresh on the overlays. Sorry about that, Shirley. And initialize that, and now we're switching back over to camels. And now things should be fixed with drones working.
Yeah.
And all the other pieces. Okay, back to your machine again, Camel. So what are we doing? Well, you're tabbing the next reference?
Yeah.
There's a key you can hit, F12, up on the function key 12. It'll just drill you in, because we've got like maybe 100 of these, or we could have many of them. If you just hit F12 on an identifier, it'll take you to its definition.
I'm trying, I think. Wait, no, not.
If nothing happens,
lock.
hit your function lock.
I did.
All right, so now we're here. SuperNumber. Find left, right. Remember what this does?
Yeah.
What's it do?
It detects what's on the right side of the equation and what's on the left side of the equation.
Yeah, so it's looking for an equal sign, right?
Yes.
Okay, so find left, right, no worries. We're good there, right? Because if we've got units, we still want to keep those on either side, right?
Yes.
Then we come in, we call new SuperNumber, and we pass in the left side. New SuperNumber, we pass in the right side. And then we just go right into here. So what's the next place we need to go to? In other words, at this point, it's too late. We've already got my left and right SuperNumbers created. And at this point, it's too early because we've just now figured out the left and right.
So when... right before we... if left right isn't equal to null, right before we declare SuperNumber left and SuperNumber right.
You want to do it here. That is absolutely one solution, right? We could do it right here, like this.
But, let me guess, there's a more efficient way
Yeah,
of doing it?
I think there's a better place for it. It's between here and here. It's between those 2 points. The place we want to go to...
I wonder where that place could
Do you know what this means when we say new SuperNumber?
Yes, we are declaring a new instance of SuperNumber, so we're creating a new
Right.
SuperNumber.
And do you remember what that's called?
What is called?
What this thing we're calling is called. It's not a method. It's starts with the letter C. O N S constructor. Hit F12 right here. Okay, we get the decimal fractionator, right? That already works really well, right? With numbers that are like, 1 1/2 or 0.3, 4, whatever, like that. It works well with numbers like this, right?
Uh-huh.
But, oops. But decimal fractionator fails with anything with a unit.
It does.
What if we found and stripped away units here?
Well then, the SuperNumber would be fine with the numbers. And then...
Right.
Oh, and
then the rest of this would work, and we're inside the constructor for SuperNumber, so we can set the units here. We could parse out the units separately.
And then later we could, we could add the units again.
Yeah, so what I think we need is we need like a number units splitter. That's what we need. Hold on, I'm checking on Karen/mom. Okay. That's what I think we need, something to split units from numbers. So I need to be able to take that and turn it into 1 1/2 and m raised to the 1 power. What do you think?
I think I was definitely wrong when I said it would be simple.
Oh, okay. So we need to build a number unit splitter. So can we do that? What are some other examples of numbers and units we want to be able to grab here? 1 bird, right? 2 meters squared. Where's that example fraction test? I think has got it. I want to put a word I can search for because I don't know what those. Oh no, wait, we put it over in the new one, mixed number. No wait, units variables test. It's over here. Here we go. I'm going to write the word exponents here, so we can go find them. So I want to be able to do something like this as well. Or your super number right here. And I want that to give me, and this is going to give me 1 and bird to the power of 1.
Yes.
Right? Not bird squared. This one's going to give me 2 and it's going to give me meters to the power of 3. You with me?
8. Oh wait, no, yeah. 2 and meters to the power.
Yeah, 2 meters cubed. Okay, makes sense? So these are our test data. This is our test data. These are our expected test results. Got it?
Yes.
All right. Can you start up our Reg Explorer? And let's see if we can get something close to that. If you need help at the beginning, I can help you out. Remember, we're going to need 2 named results. One for the number part of it, and one for the units part of it.
Okay. I am not sure where to start.
I'm kind of with you. So let's run it. At the very least, we're going to run it.
Yeah. Control A, backspace.
Wait, don't delete the pattern that's there, because it's already got stuff we want to work with. The reason I say don't delete it, I'm going to move my mouse over here, is because this is kind of hard to type in and remember that syntax for me. Okay, does that make sense?
Yeah.
I kind of feel like, so how do we find it? If we look at the examples we typed in, let's go back over here. Right, in all of these examples, we're basically saying, give me all the text. I basically want to find the last valid number. So I guess we could do this, is we could say, well, what are all the valid number characters? And say, get all of those as one piece, and then anything after that is the rest. I think that's the way to do it. So let's put in the sample. Let's put in this as a starting sample right here. Okay. And we're going to say number as the first part of it. So we need one of those on one side. And I'm going to just kind of do that. So we need number on one side, And number is going to consist of any number of digits or the space. Oops. This did not have the end here. So now look at this. This is really useful. See down here?
Mm-hmm.
It found this part of it. So I need to add the / here as a possible valid character. Okay, good. What if I have, so it's found that now. And then what I need to do is create the second part of it that we're going to call units. And this might have one or more spaces, but it doesn't have to be. It could have 0 more spaces, like that. And then units, and oh, hold on, because this then needs to be all the way to the end. How do we keep this from happening? I guess the units have got to start with, it's got to start with a word character and then followed up by 0 or more numbers like that. There we go. See it? See what just happened?
Yeah.
Units are now M. Okay, so we're looking, it's got to have some sort of letter. Units have always got to start with a letter. That makes sense. Okay, next we need I'm going to say $sign here. We need to check to see.
Not $sign.
This works.
Not $sign.
I think it is $sign.
No, it $sign marks that it's the end, but we're looking for 2 SuperNumbers.
No, when this comes in, it's only the one. We've split it on the outside. It's coming. It's coming in, I think, from here, right? So we split just the left.
Right.
What'd you say?
Oh, right.
All right. Okay, so I wanted to grab this next and see if we got meters cubed.
Can I do something really
Not
easy?
found. So see this?
Can I try something?
Yeah, you can. Don't stop at what I've done though.
I won't. I want to. What about 1 2/3? Sure. Or wait, times and 1/2, and then we have this all over. Can we do this?
No, we don't have support for this. We only have support for simple expressions, which is one operator in the middle. So you have to copy this answer and then take that answer and then use it again. Okay?
I thought we did. Never mind.
No, we haven't written that yet. We only have support for this. But this could lead to something else. All right. Okay, this doesn't work. Doesn't find it because at 3 it doesn't know what that is. What if I did this? Use the caret symbol in the number 3. Doesn't support that either. See that? So we come in here, we need to add the caret symbol as one of the optional characters it can support.
Period. Wait, just do period.
No, because I don't want to support anything. Do we want to support anything?
No, because that would include numbers.
No, maybe you're right. Maybe we do.
But then we would be able to have number units, and it would just be.
Yeah, no, I'm thinking you're right. What if we just did this? And now everything works. I think it's a really good suggestion.
Wait, go, can...
Yeah, I think that's the better suggestion.
What about...
Just do... Go ahead.
Huh. I'm surprised it can handle that.
Because all it's doing, it's looking for the one letter character. And then it's taking everything else at the end. Now, we don't have that. Uh-oh. We got one slight problem here. We need that to fail. And why is that failing? Why is that failing? It says units is 2. a word character? I thought a word character must be the number 2.
No, a word character can be a digit.
KidzCode, where are you? We need your help! Oh, yeah, alright.
267 is here.
Here, White House.
Alright. I've got this wrong, I think. I'm looking for a letter A through Z.
Yeah, because the \W is any letter or any number.
It's a dash. Any letter, any number? Okay, that's why it's failing. Okay, so now we're in a better place. So it's got to have some letter A through Z. Okay?
Yes.
That feels better. Alright, so now that works. Now we can come in here, grab this test, bring it in here. That now works. Units or meters cubed. Throw in one bird. Good. 1.5. There it is, like that. Okay? Got it?
Yes.
Put in meters. What if I did meters per hour? Still, the units are working,
No music.
right? What'd you say?
There's no music.
Oh, let me fix that. There you go. How you doing, Jeff? Genius 27. Yeah, so this looks like this all is working. For H, be right next to it, over here, it's all good. That's it. We're calling this number unit divider or something? What do you want to call it?
Find number unit so that it's consistent with find left right.
Okay. 60 is a great argument. Go ahead and copy that clipboard. Tell me that guy. Oops, sorry, my bad. You did it now. My mouse is off the screen. Alright, let's figure out where to put it. Don't close it down. Don't close it down. You're going to want that in because then you need to change it.
I know, I closed the other one down.
Okay.
Not this. It's still up. Rigid.
Got it. That's good enough. Alright. Where are we going to put that?
It doesn't matter because we're gonna move type to file anyway, so.
Well, yeah, we just got to do it outside, but it's kind of like, I guess I kind of want to look over at the file structure over here and see where we're putting the other ones. It does matter from the standpoint of, we've got to put it in one of these 3 projects. Do you have an insight on where we should put that in terms of the project?
Probably in SuperCalc because that's where.
Okay. So yes, you could totally put it inside here. And it probably would work. Actually, it wouldn't work. It's not going to be, because it's actually got to be in the core. Because that's where we have SuperNumbers code down here. And SuperCalc is just our main window.
Yeah.
Notice all it has is that one main window, and that's it inside of it. So we would put it in here. Notice we also already have the regex helper down here. And we've got like our equation finder and all those other pieces. So I want you to paste it here, and then you can move type the file in here. You can use selection increase, that trick I taught you,
and
the
then
left arrow to get close to that top right up there. Wait, it looks like we missed it. Left arrow, not right arrow. Use selection increase right in here. Not there, go back up where you were. Line 31. Line 31 is the end. No, this is what we already had. This is the piece we already had. Line 31 is the end. One more time, I think. One more time. I'm looking for that top to change. One more time. Look for that to have the one class. There it is. Now hit the left arrow. So it's just 1, 2, 3 keystrokes, left arrow, and now you're here. Now you can hit the coverage key. That's 5. All right. There's some examples right there. Here's what I want to do. I want to create some test cases for this. Bear with me a second, but we should have been doing this with all the others pieces we created as well. I'm going to create a new, so I'm just going to do it. I'm going to come up to the top, I'm going to create a new test class. going to call this reg x test. Like that. We're going to say test find number unit. Like that. And then we're going to say this dot create, and we're going to give it some input. Say 1 1/2 meters. Like that. We're going to play that as local, and then we're going to do an insert equal. See if you can figure out what I'm going to do here. What would go on the left? If on the right side I put in number, what would the test piece be here that we expect to get back from that? And while you think about that, I'm going to do a second one for
any number
units.
any amount of numbers from 0 through 9.
Well, think about what find number unit does.
It finds the number and it finds the unit.
Right.
Oh, so it would just be 1 1/2. Sorry, I didn't see
There
that.
you go. So right here, 1 1/2. And right
then-
down here, what would I expect to have find?
M.
M. Good. So this is powerful to do this because we don't want this to break ever, right? I'm going to come down here and I'm going to recreate it, and I'm going to give it a different set of
Oh,
units.
wait.
Yeah. What? I'm waiting.
I think. No, never mind.
Never mind, he says. Let's go to the other test that is the unit variable test. That's what I want. I want some of these. And I want to go, let's throw something in there. Make it cute. That. And what am I expecting to see here? What's this test? What am I expecting the number to be here?
I'm not sure.
Well, what's the number up out of this? I'm creating it based on 2 meters cubed. Well, okay, what's this part?
M. Oh, so meters cubed would be in units.
So I want M here or meters cubed?
M cubed.
Okay. And what do I want here?
2.
Okay, very good. Okay. I think we have one more test.